4.4, trig of any angle. Basically what we're going to be doing in this section is just practicing. So kind of culminating everything that we've done, except for the law of sines and law of cosines from this chapter, and just practicing a little bit. So I am going to be doing a lot of, I recommend you pause, I'm going to pause so we can check answers. Highly recommend that you do that this section because we really are at the end of the chapter. You want to make sure that you can do this. So I'm going to work through the examples. We'll pause, we'll check, pause, check, keep going, and then make sure that you ask any questions in class if you have them. Okay, so let's start. So the first thing that I see is I need to find all 6 trig that satisfy the following. Well, as you know, I know you've heard me say it a lot, I'm a picture person. So let's go ahead and draw a picture for negative 3 pi over 2. Well, negative 3 pi over 2 is going to be coterminal with pi over 2, so that's up here. All right, whenever I'm on an axis, I always put the point next to it. So this is 0, 1. All right, remember that the x value corresponds to my cosine and the y value corresponds to the sine. So I'm going to pause. I highly recommend you do the same. And I'm going to fill in all 6 trig. And then when you're ready, unpause and let's check. Okay, so here are my 6 trig. I did keep in mind that my sine was my y value, so I used the 1, and my x was my cosine value. And then remember, when you find the reciprocal of 0, it's going to be undefined, and then the reciprocal of undefined is going to be 0. All right, let's take a look at the next question. I'm going to do the exact same thing. I'm going to draw myself a little picture here. Get a good idea of 19 pi over 6 and where that's located. And then I'm going to pause, and we're going to check. All right, so 19 pi over 6, so that's going to be 6, 12, 18, 19. I just need to go a little tiny bit. It is a pi over 6, so I didn't make it very steep. It's actually quite shallow. So from here, I'm going to pause. I'm going to go ahead and fill in all of my 6 trig. I highly recommend you do the same, and let's check and see. Okay, so here are my 6 trig. Because of my picture, I find it very helpful. I noticed that the sine, the y value, is actually pretty shallow. It doesn't go down very far, so that's the half. But it's also down, so it's going to be negative. Then my cosine, that x value, is actually pretty long, so that's the root 3 over 2. And then I do that quick check. I'm in the t quadrant, which means tangent and cotangent are both positive. Okay, moving on to the next one. Oh, this one is not in the unit circle, and I think I'm going to need a bigger picture, at least for me. So, go ahead and set this up. And then once we have our picture up and going, I'll do the same. I'm going to pause, fill it in, and then you'll pause, hopefully, and then do the work, and then let's check. Okay, let's take a look at this second piece of information first. So I see that sine theta is greater than 0. Sine corresponds with my y's. I want my y's to be bigger than 0, which means I want my y's to be positive, which means I need to go up. So that means that down is not going to work. So let's get rid of the down part. All right, the next thing I need to take a look at is the first part. I'm just going to look at the sign on it. It's saying that cotangent is negative. Out of the 2 quadrants I have left over, cotangent is negative in the second quadrant, which means it's definitely not the first quadrant. Now that I've gone ahead and limited it down to this second quadrant, I'm going to go ahead and draw my triangle in that spot. And the one thing that I am going to do, and I'm pretty sure that you could have predicted this by now, so I'm not a big fan of using the reciprocal function. So I'm just going to go ahead, kind of get my stuff set up down here, because I do have nice organization that I think I use. And I'm going to go ahead and find tangent, because tangent's one of the original functions, and I think those are a little bit easier. So I'm going to take what's given to me, and I'm just going to flip it over. Okay, now that I've done that, I'm going to go back to the picture. So I've got opposite, which is going to be 7, over adjacent, which is 9. Now you need this to be negative. Let's be smart about it. The 7 is not going to be negative because it's up. The 9 is going to be negative because it is left. Okay, now that we have that settled, I'm going to go ahead and pause. I'm going to fill in using the Pythagorean theorem, and I am also going to do the rest of my trig. So I highly recommend you pause. When you're ready, unpause, check and see if we match. Okay, how'd you do? All right, well, let's check. I am in the S quadrants, so the only ones that should be positive are sine and cosecant, which they are. I went ahead and found the hypotenuse, and I got root 130, which can't be simplified. It's a product of 13 and 10, and then 10 is a product of 2 and 5, but 13, 2, and 5 don't match, so there's no way that you can simplify that. And I made sure to rationalize. So I think that does it for the first 3 examples. Let's go to the next slide. Okay, got a couple more that we need to do. And then number 4 is a lot like the previous question, although the restriction's just a little bit different this time. So I know you're surprised I'm drawing a picture. All right, so this first part that I'm going to look at, well, I'm actually going to look at the second part first. I don't even know why I always look at the second part first, but I do. It's just a habit. So I want to be between pi over 2 and 3 pi over 2. All right, so literally, if pi over 2 is up here at the top and 3 pi over 2 is here at the bottom, and I want to generate the actual distance from pi over 2 to 3 pi over 2, then that means I'm going to have to be on this right-hand side somewhere, which means this is taken out. Okay, now let's take a look at the next one, or really the first one, I guess. So sine, I just care about the sign of it, the SIGN of it, if it's positive or negative. It's negative. So out of the 2 quadrants that are left over, the only quadrant that is going to be negative is the bottom. So let's get rid of the top. So it looks like we've limited it down to this quadrant. I'm going to go ahead and fill in the information that I would normally fill in. Put my theta in there. Remember, it's always referencing back to the x-axis. Sine is opposite over hypotenuse. So a good thing to note here is that I went ahead and just put the negative on the 3 and didn't even think about putting on the 5. That's because the hypotenuse is never going to be negative. The legs can be negative depending on which way they are, if they were left or if they were down, but the hypotenuse will never be negative at all, guaranteed. Okay, so I'm going to stop now. I'm going to go ahead and pause. I highly recommend you do the same. I'm going to do the Pythagorean theorem, find the side that's missing, and I'm going to label out all 3 of my trig. Okay, so I lied just a little bit. I didn't really do the Pythagorean theorem because I recognized the 3, 4, 5 Pythagorean identity, or Pythagorean triple. So there was no reason for me to do that. Now, if the 5 is the hypotenuse and the 3 is one of the legs, the other leg is 4, guaranteed. If you're not sure about it, you can do the Pythagorean theorem. I just didn't think that it was necessary. Okay, question numbers 5 and number 6. These ones are a little tiny bit different, but not a lot. Still, the idea behind it is, can you draw a picture and find the sides? So we're saying that the point 11, negative 2 is on the terminal side of an angle in standard position. You guessed it, I'm going to draw a picture. So, I'm not going to make it the most accurate picture, I just want a good idea. So if it's 11 to negative 2, so I'd go 11 to the right and I'd go negative 2 down. So maybe somewhere in that ballpark. Right there is going to be the terminal side. Okay, so let's just make a triangle out of this. So if I make a triangle out of this, and I'm just going to go ahead and plug in the values where they belong. I went 11 to the right, so that's 11. And I went 2 down, which means that's negative 2. Now it looks exactly like the previous question, although the restriction wasn't given to you because based off of the point, you knew exactly where you needed to put it. So I'm going to pause it again. I'm going to go ahead and use the Pythagorean theorem and figure out what my hypotenuse is going to be, and I'm going to find all 6 trig. I recommend you pause so we can check. Okay, so here we have the 6 trig. You'll notice that I showed my Pythagorean theorem and I got down to root 125, but that can be simplified. So I ended up with 5 root 5 out of that, and I went ahead and plugged it into my formulas. I am in the C quadrant, so I made sure that my cosine and my secant were both positive. Everybody else is negative. Now 6 is exactly like the previous question. Although it can be a little tricky because there is so much flying around all at once. So I think I'm going to help you set up the picture, and then I'm going to show you something that I think is pretty slick. So if we plot this point, we would go left and down. So that means we're somewhere in that ballpark. and we would go left 2 root 3, and we would go down -8. Okay, so what I would do is I'd go through and do the Pythagorean theorem on this. So I know it's going to be -8 squared plus -2 root 3 squared. So it's going to give me 64. Now on this one you square it, you have to square the 2 and the root 3. So the 2 squared is going to be 4, the root 3 squared is going to be 3, so 4 times 3, that's going to give me 12. So that's going to give me 76. Now I'm going to go ahead and simplify this, and I think 4 goes into it, and 4 goes into it 19 times. So when I simplify, I'm going to get 2 root 19. There's my hypotenuse. I'm going to go ahead and put that up here. Now there are a couple ways that you can handle it from here. You can go ahead and do what you would normally do and do your sine, cosine, tangent, cosecant, secant, cotangent. But if you take a look at this picture, every single one of those sides can be simplified because they're divisible by 2. So I think that's what I'm going to do. I know that just by looking at this, I'm going to have to simplify those fractions later anyway, so may as well just do it now. So I'm going to rewrite it, and I'm going to divide all of the sides by 2, just squishing it down a little bit. So that means that this is going to be negative root 3, and this is going to be negative 4. I'm already liking this better, the numbers are much smaller, and the hypotenuse is root 19. Now, find all 6 trig, pause, and let's check. Okay, so we have our last 6 trig, and I did use the simplified triangle. You'll get the same thing if you use the original triangle, you just would have had to simplify the fractions more. Whereas in the case that I followed, I'd already simplified, so I didn't have to afterwards as well. One of the things too that you'll notice is that this is a little tiny bit different. It's the first time this has actually come up. If you take a look at cosine, so let's do a little bit of cosine work off to the side. We know that cosine is actually going to be adjacent over hypotenuse, which is negative root 3 over root 19. Now, if those could be simplified, I would simplify them. They're both inside the radicals, so it's possible to actually simplify them if maybe it was an 18, but with a 19 it's not going to do anything. So I'm going to go ahead and rationalize just like I normally would. So I get that 19 on the bottom. You'll notice that, again, the 3 and the 19 are both inside the radical, which means you can multiply them. Just keep them inside. And when we multiply them together, we are going to get 57. Now, if that can be simplified, you must. However, if you take a look back at the 19 and the 3, neither of which could have been simplified, neither of which have a factor in common, that means that the 57 is not going to be able to be simplified either. Remember to ask for help if you have it in class.